Before we can call functions, we need to define them. The function definition contains the following information: the function name, the function parameters, which are inputs, and the function behavior. Here's an example. The first line is the function header, and the indented lines that follow the header is the function body. The function header is in the following format. Function underscore name is the function name. Function naming rules are the same as variable naming rules. The function name is always followed by round brackets or parentheses. The brackets contain 0 or more comma-separated function parameters. Function parameters are variables that contain the function inputs. Parameters are assigned values when the function is called. Here's an example function definition with no parameters. Here's another example with 3 parameters, x, y, and z. Note the commas in between the parameters. The function body is a set of Python statements that are executed when the function is called. The function body may contain a return statement. The return statement instructs Python to exit the function call and return to the call site, the line and tab where the function was called. The format of the return statement is return value. Value is the output of the function. It is also a Python expression. And finally, it is optional. If the value is missing, then the output of the function is none. Here are some examples of valid Python return statements. If the function body does not contain a return statement, then Python executes the entire function body and outputs none. Let's look at an example program. As always, Python begins at line 1 tab 0. The statement at line 1 tab 0 is def add 5x. This is a function header. The function name is add5. This function requires one parameter x. Python is going to record the function name and the location. The add5 function body is in tab 1, lines 2 and 3. Line 4 is in tab 0, so it is not part of the function body. Python skips lines 2 and 3 because the function body is only executed when the function is called. When we want to jump to the function body, we make a function call. For example, add5 7 calls the add5 function with one input value 7. The function call format is as follows. The function underscore name is the name of the function to jump to. The function call includes 0 or more comma-separated function arguments inside the round brackets. Arguments are the function inputs. Arguments are expressions, so they can be values, variables, or operations, among others. At a high level, the function call consists of 3 steps. 1. Send function input to the function. 2. Execute the function body. And 3. Receive function output, if any. Let's explore each step. Python begins by evaluating the function arguments. Python then saves a copy of the current Python state in the context stack. The current state is needed to return to the call site after the function body has been executed. Finally, Python inserts argument values, the function inputs, into new variables and jumps to the function body. For example, in the simulator above, line 5 contains an assignment statement b equals add5a. As usual, Python first evaluates the expression to the right of the equal sign, which is the function call add5a. Here are the first 4 steps of the evaluation process. 1. Evaluate the argument a. The value is 5. 2. Push the current state to the context stack, including the current line, which is 5, and current tab, which is 0. 3. Inject the argument value into a variable. The variable name is the function parameter x, and the variable value is 5. And 4. Update current line to 2 and current tab to 1. Like the MIPS assembly JAL instruction, Python jumps to an arbitrary part of the program. But Python also provides a separate isolated context by saving the current state and resetting the various stacks and maps. For example, variables created inside the function body are automatically destroyed when Python returns to the call site. These variables, also called local variables, cannot be used outside of the function. This means that function authors can freely change the function body without affecting other parts of the program. Note that function parameters are also local variables. The statement at line 2, tab 1 is z equals x plus 5. This adds x and 5, then stores the result in z. Since x contains 5, Python stores 10 in z. Then Python moves to the next line. The statement at line 3, tab 1 is return z. When Python encounters a return statement, Python first evaluates the return expression. Then Python returns to the function call site. Thus, in the example above, Python first evaluates z, then pops from the context stack and restores the current line, current tab, and various stacks and maps. The return expression value, which is 10, is the output of the function call add5a. As with any expression, the output is pushed to the value stack. The function call evaluation is complete. Python is now back in line 5. Python completes executing the assignment statement by popping the output from the value stack and storing it in variable b. Python has now finished executing the program. Here's the summary of the example program. 1. Store 5 in variable a. 2. Call the add5 function with argument a. The add5 function adds 5 to a and returns the sum, which is 10. And finally, Python stores the function output in variable b. Recall that LWPython converts the add operation to the add function call. For example, 3 plus 5 becomes add 3, 5. But we did not define the add function, so how does LWPython call this function? We don't have to define the add function because it is a special function that is built into LWPython. When LWPython sees an add function call, rather than searching for the function definition, LWPython will simply add the two arguments and push the sum to the value stack.